Hi, this vid is a summary of most of my own observations, photos and videos I've been making over the last few months. I'm not a scientist or a professional by any means, I'm just attempting to see and show the Earth for what it is, and to try and help people from being led astray by deceivers who just want to promote a potentially dangerous belief. If you're a curious mind wondering about our planet, or if you're just having trouble debating you know who, this video is for you. The Northern Hemisphere, it truly is an amazing place, full of so many destinations I've wanted to visit my entire life. But I live in the Southern Hemisphere, where to most of you I'm upside down, but to me you're all upside down. My home, beautiful Australia. I live on the east coast, about a 2-hour drive north of Sydney on a waterway called Port Stephens. All of my Earth and sky observations are made right here. Only 12% of the Earth's population lives in the Southern Hemisphere. This has given me the opportunity to make observations of the Earth that 88% of the world can't make. The main differences I observe are the way the sun, moon and the stars move and appear in the sky. Everything is reversed, which makes for some really dramatic observations. First, I'll show and talk about some of the observations I've made which are unique to the Southern Hemisphere, and then I'll show the observations I've made which anyone in the world can make. I'll begin with the North Star. Where is Polaris? There's a whole bunch of star maps and apps which some are good, some completely suck, but a few have features that work really well for different situations and individuals. One of the more complicated apps, Redshift, has a decent follow sky feature. Wherever I point the camera, the app will show me what's in the sky and where the horizon is. It wasn't until the shape of the Earth was being put into question by those I don't want to mention yet, that there became another use for this feature, pointing the camera at the ground. I had done this in the past as a novelty, but when it came to trying to show the shape of the Earth, I could now show in real time where celestial objects were, while not in my sky and under the horizon. One of my first targets was Polaris. Here's a screenshot from the Redshift app, while I had the iPad camera pointed at the ground. You can see Polaris is to my north. Probably the most noticeable is the fact that Polaris is minus 30 degrees below the horizon. Keep in mind, wherever I point the camera, the app, while not perfect, has the object lined up, whether it's the sun, moon or the stars. This is why I know what I'm seeing is real. And just to be sure about Polaris' position, it's also below the horizon at night. Here's a simulation of my northern sky from dusk till dawn. Polaris is at the bottom in the centre. This is how I see the stars with my own eyes all year long. So the conclusion from this observation is, I'm in the Southern Hemisphere and the Earth is round. One of my favourite observations is looking at the stars. The first pic I want to show is an upside down Orion. I left in the timestamp and the roof of a house to show that I haven't flipped the photo at all. Personally, I think Orion is probably one of the more dramatic constellation differences when viewing the northern sky from the Southern Hemisphere. Next is the Southern Cross, or Crux. This constellation is on the Australian flag and probably tattooed on half the population. Everyone in Australia, including me, can see these stars move through the sky and around the southern pole stars, just like people in the northern hemisphere would watch the Big Dipper move around Polaris, the northern pole star. This is the view of the northern sky from California. It's one I've never seen. These stars and constellations are mentioned in movies so many times and I've never seen them, because here's my view of the northern sky. It's a huge difference. To me, to observe, say, the Andromeda Galaxy M31 with my telescope or binoculars, I have to wait for the right time of the year and then it's only visible for a few hours a night. I just can't see why I'd need to do that on a flat plane. So from my star observations and experience, it's pretty clear I'm standing in the southern hemisphere of a gigantic ball. And then there's the moon. When I look at the moon, it doesn't quite look right. Compared to how it's shown in popular media, I see it almost completely upside down. This is another major difference of looking at the sky from the southern hemisphere. I do see it rising from the east and setting in the west, just like the stars, but I'd always been taught from that amazing thing called education that the moon is actually orbiting in the opposite direction, west to east. This would be a huge flaw for the flat one's theory, so I thought I'd test it. If the flat ones are right, the moon should be moving the way it appears to be, from east to west, right? So I watched the moon over a few clear nights while Saturn and Mars were close together to give me a nice sort of reference point in the sky. And what do you know? The moon was actually a little bit further east each night. When I look at the sun from Australia, there's obvious differences to the northern hemisphere. I made a basic diagram of where I see the sun rising, where it is at noon, and where it sets. I thought using the flat earth map would be more of a more balanced observation. After checking the sun over a few days at these three positions, and also from my experience of watching the sunrise and set in Australia for almost 40 years, I was able to make this diagram showing where the sun rises and sets during the Australian summer. The sun arc I see clearly doesn't fit the flat earth map. A flat one who didn't believe what I was seeing put out an open challenge online to see if anyone could show the same sun arc I was seeing onto a globe earth model. So I found a really cool globe earth sun path simulator, put in my position and date. The sunrise, noon and sunset all matched up with what I was seeing during summer. Another sun observation I did was matching the angle and position of the sunset during summer. I found that the sun was actually setting and rising south of east and west, or below east and west. Seeing this happen in the southern hemisphere, for me, blew the flat earth map into the freaking stratosphere. According to the FE map, there is no possible way I should be seeing the sun rise and set in this direction. So my conclusion from this is, what the bloody hell is wrong with you all? The freaking earth is round. Alright, it's time for my baby. Satellites are something that I thought I'd never really be able to do any kind of useful observation to back up the proof of their existence. But a friend online who was defending some recent satellite images of Australia with clear skies asked me if I could verify the current weather conditions that were being put into question by some typically illogical flat ones. So I looked outside. Yep, it was clear. And I was able to verify it with a photo that yes, there were no clouds in the sky. A light bulb freaking slapped me in the face and Operation Himawari was born. I realized that I could take a series of photos every few hours each day for about a week to see if my local weather conditions matched up with Himawari 8. And guess what? Every single time I took photographs, they matched up with the corresponding satellite images. The claim from conspiracy nutjobs is that Himawari images are nothing more than radar images put onto a CGI globe. But Doppler radar can only detect rain within about 50 to 100 kilometer radius, and regular radar can't see through large objects like a weather system and then see another weather system behind it. Anyway, I consider Operation Himawari a fairly successful operation, and what I learned from this is satellites in space are real because the Earth is freaking round. So this is the observation that anyone in the world can do. You just need a clear view across at least 4 miles of calm water, like a river or a lake or something like that, with a distant shoreline on the opposite side. It just so happens I live near a waterway which is about 4 miles across and has bright sandy beaches and sandbanks on the other side, and relatively no waves, giving me a nice unobstructed view. This is my observable curvature observation I put together, or frontal curvature. The photos are zoomed in to the opposite shoreline. In the top picture the camera is about 15 feet above the water, and the lower picture I have the camera down to about 2 feet above the waterline. The beach in these pictures is actually a sandbank with vegetation, and the photos were taken close to low tide, so the height from the waterline to the top of the sandbank would be at least about 3 feet high. I have noticed that this observation is better at low tide as there's more of a shoreline exposed. I have tried this one several times, I have noticed the distortion from refraction during different weather conditions, but the effect really is minimal. It's easy to tell the difference between refraction and a perfectly clear horizon. So this observation shows me that the shoreline is being blocked by the curvature of the Earth, because the Earth is freaking round. Look at the sun from Australia. When I look at the sun from Australia, there's obvious, fucking hell, talk proper, you dumb fuck. Another sun, I'm sick of saying observation already.